It's time to talk more about your organization. How can we make you and help you in that transition, in that BIM implementation? Successful implementation of BIM requires a careful and structured approach that takes into consideration the many integrated components of a firm's business, starting with the vision and leadership extending to individuals who will apply BIM on their day-to-day execution of projects. Pilot projects are one component of a well-thought-out BIM implementation plan. That's why in this section, I will outline recommended steps that you can take and how we can assist you and your organization in planning that deployment of BIM projects. We'll talk more about establishing main business objectives, how you should assess your current resources and workflows, and how you can identify a pilot project and develop the right strategy and schedule to get to the outcomes that you need. So let's start by talking more about this process. So BIM, and this is a completely different process than the one that we're used to traditionally. So we have to redefine design and documentation process. We have to be able to understand that process. One of the many things that you'll start hearing, and you probably are already dealing with, is level of detail, or LOD. I see a lot of my clients saying, oh yeah, we have LOD 300, and sometimes it's not so clear what LOD 300 means. So in those couple of slides, I'm going to try to explain to you the different levels of detail that are required when you're implementing BIM. Let's start by LOD 100. LOD 100 models include elements such as masses and are used for preliminary studies such as conceptual design and overall project phasing. So analysis based on their location and orientation can be performed. Quantities based on overall area and overall volume can be obtained, as you can see that to the picture to the left. On the other hand, LOD 200 models include elements in which masses have been replaced with generic models. So analysis based on overall system can still be performed, and quantities based on specific elements can be obtained. So as you can see here, we have a schedule for walls. It displays the different types of the walls, their width, their length, their area, their volume. So the major characteristics of components are displayed in this schedule and is available for you if you need to have a quick takeoff. When we move forward with LOD 300, that's when we talk more about CDs. So level 300 models include elements in which generic components have been replaced with fully defined assemblies. Analysis based on specific systems can be performed. Quantities based on materials can be obtained. So those same walls that we had before, now they have material, and the schedule displayed here to the left talks more about the material and the volume and the different components, how they've been more specified and characterized. So as you can see, this takeoff is more specific, and we definitely use it in CDs. For level 400, now we're talking about fabrication. So these models include elements that are accurate in terms of size, shape, location, quantity, and orientation with complete fabrication. They also have detailing information. So as you can see here, you have some text, some dimensions, some tags, because at this level, we're more doing this for fabrication. So this model is representing the wall, and you can definitely use it for energy consumption, for clash detection, and Navisworks for sequencing and cost. And the highest level of detail that we have over here is level 500. Level 500 models include elements modeled as constructed or as built. Elements are modeled to accurate size, shape, location, and orientation. Non-geometric or physical attributes can also be included as parameters to their geometric shape. So as you can see here in this schedule, you have element ID, you have an associated Revit ID for that particular element, but it also has parameters for inspection. So here it includes a date for when it was last inspected, when it will be inspected again in the future, the priority, the condition. So these are all parameters that they are not modeled, but they are relying on a modeled element. Now that we have somehow of an understanding of different LOD levels and how detailed they are, let's talk more about how you can establish your main business objectives. A BIM implementation must be supported by the business as a whole. It cannot be an IT initiative or an R&D initiative or done solely at one project level or at one discipline level. It is essential for us to succeed in this implementation to have a clear and well-articulated vision from executive leadership of what BIM should, what do they want to achieve for this particular organization, what the principal elements of that transformation are, and what this evolution would look like at various stages. This is not just a vision statement, it is a narrative where BIM will take, where do you see your organization in 5-10 years? To truly acquire the advantages of BIM, executive leadership must be capable of positioning BIM within the strategic objectives of the entire organization. Some elements to consider for an effective BIM vision can be the following. One, it should be inspirational and aspirational. The vision must be far-reaching and sufficiently aspirational to unite the various elements of the organization. It should also educate, so your executive leadership may need to be educated on BIM and consider its impact in setting corporate strategies. A good way to begin is to establish a relationship with a trusted advisor, such as Microdesk. Third, you have to be able to define the 5 W's, the who, the what, the where, the when, and the why. And these are not easy questions. They will be challenging, and sometimes it might require executive leadership to take some risks. And finally, you need to allow yourself to set milestone accomplishments. Creating milestones helps the organization to overcome the initial paralysis of facing what might feel like a monumental task. Meeting those milestones also helps to create short-term ones that can generate energy and drive that will help you focus on your end goal. Now that we have a BIM vision, the BIM leadership team must ensure that that vision is translated into actionable tactics to produce the desired outcomes and performance in line with the organization's strategic objectives. Managing change in any organization can be very difficult and requires creative strategies tailored to each organization's culture and goals. Here are some tactics for managing change that we recommend. One, you have to be able to bridge the gap. Action by executives and BIM leadership must be accompanied by bottom-up approaches, such as assessments, education, and monitoring of all this progress, all those different phases. Also, communication is key. So a high-profile communication plan demonstrates to all stakeholders the organization's commitment to BIM. It also helps to inject energy into that transformation. It helps in bridging the gap from executive theorizing to a daily reality of an end user. Another important factor is education and training. Adoption of BIM technology requires new skill sets, new ways of working, and that demands an investment in training to ensure that the right people are trained on the right tools and the right skills to deliver the right project. You also have some legal considerations to take care of. BIM tools and their associated processes can impact the contractual relationship between the owner and their delivery partners. BIM-enabled collaboration is a significant change to traditional processes, which should be addressed upfront with the project stakeholders. And last, we want to talk about quality control. So how can we address quality control? Project reviews permit your BIM leadership team to evaluate lead measures and the effectiveness of BIM technology, the standards, the process itself, and being able to do that will help implement BIM on a particular project. Doing that, BIM leadership can catch errors, can improve standards, and can replicate best practices. One good thing to keep in mind is that you need to determine key indicators to measure the organization's progress towards your goals. One good indicator can be BIM maturity, which measures the organization's capability to perform BIM within the organization on several projects. With the groundwork done, it's time to pick a pilot project. Now, BIM practitioners take a number of approaches that include completing a fake project sometimes, or creating a competition, or redoing a recent project, or even starting a new project, which is kind of my favorite. All these are valid and will depend on the acceptable level of risk and manpower available to undertake your current work. Any pilot project should include measurement at all key stages to really understand how BIM has improved the design and construction process. But where do you really start? First, you have to remember to review the existing functions and processes in your office. What types of projects does the office do? What information is needed in which phase of the project? What is the flow of information over the life of a project? You also have to review the software's potential impact on those processes that you just mentioned. Then you'll have to create a timeline of milestones that can be measured. And then you have to choose a project and choose the right BIM team for it. Because once you set up your goals and you choose a project, you have to choose the right team members that will be able to deliver that project. In this case, establishing their roles and responsibilities is key. Not only that, you also need to educate them and train them, and to outline the different phases of your project and the different models that you are planning to deliver. One thing to keep in mind is that developing office standards and library and then content development is very important. You obviously won't be able to develop all those on the very first project, but it's good to keep in mind that BIM implementation depends on having some office standards and some library. Now that we mentioned, we talked more about the vision, we spoke more about how to pick a project. You have a project in mind. Good. What's the next step? You want to execute that project. And I'm sure a lot of you are already familiar with this term, BEP, or BIM Execution Plan. But what we want to talk about here, we can't really cover in detail how to create a BIM execution plan. But what I want to try to do here is give you an idea of what it is and what should be in it, so that if you're an MEP firm and you received one, to know how to interpret it. So the BIM execution plan, or what we call BEP, is designed to effectively communicate to all key project stakeholders the overall vision and implementation details to follow throughout a project. It is continually developed and revised as needed throughout the whole project lifecycle. The entire team will gain value through the increased level of planning by reducing the unknowns in this implementation process, and thereby reducing the overall risk to all parties involved in this particular project. So the purpose of a BEP is to define the scope of the BIM implementation. And as you can see over here, this picture to the right is a really good summary of the BEP, because you can see that it includes the level of development or level of detail. And as we saw earlier, at 100, you have a conceptual level. At 200, you had an approximate level. At 300, you have a more precise, 400 fabrication, and 500 for as-built. We can also see that the purpose of the BEP is to identify workflows for your BIM tasks and to see what are your BIM goals and how to be able to achieve those goals. It also allows you to define information exchange procedures between different parties, and it describes the infrastructure needed to support this implementation. What are those main components that you will be able to find in a BIM execution plan? You'll be able to find the project information, the different BIM uses, the process design, the information exchange, the data requirement, the collaboration procedures, and the model structure. But how do you really get there? You follow 4 steps. The first one begins by identifying BIM goals and uses. And then you have to design BIM project execution process. And then you'll have to develop the information exchanges. And then last, you have to define supporting infrastructure for BIM implementation. And I'm really not going to get into too much detail explaining this. I can definitely provide some links that you can take a look at later on. But it's good to understand that you always have to think about your goals. Which brings us up to the next slide, which talks more about your goals, the BIM goals and uses. And this is just simply an outline of a sample that you might write in your BIM execution plan. In order to identify your BIM goals and uses, we should always begin with the end goal in mind. So what is the ultimate purpose of this BIM model? What is the client asking for BIM? Why should the client be using BIM? Goals should be based on the project performance. For example, we can say our goal is to reduce schedule duration, or to achieve higher field productivity, or to reduce cost of change orders, or to improve overall quality of a project. Goals should clearly define potential value and should always be measurable. They can also relate to advancing the capabilities of the project team. So your goal might be to increase your improve your design quality. So right here, let's take a look at this table and give you a few examples. So you have 3 columns, and the one in the middle talks more about the goals, and it defines the objectives and values added. And in order to have a list of goals that you think are appropriate for your project, you should ask yourself the question, what do we want to achieve? How can we add value by using BIM? And then we move forward to the column on the right, which is the BIM uses. And it's a method of applying BIM to complete that particular goal. So you ask yourself, what can we do with this BIM model by achieving that goal? How are we using the additional data? And to the left, we have a priority column. And this is essential because, of course, you're not going to have one goal on this project. You're going to have several goals. Some of them are more important than others. So, for instance, if you want to be able to increase effectiveness of sustainable goals, that's priority number 1, you have to use it for engineering analysis and other types of analysis as well. If you wanna record an accurate 3D model and use it for FM, you need to be able to do 3D coordination. So each goal can have different priorities and can have different uses. What are some of the workflows that you can use? This slide is definitely not a holistic list of all the solutions available. And it's simply a summary of what your organization can use to implement BIM at different stages. I know we're all fans of Revit, so we can see here that in the pre-design and design phase, you're using Revit and you keep on using it all the way to the end. We have other tools that you use in pre-design. Format 360 is one of them. Dynamo is one of them. InfraWorks is another one. Same thing with design. Another favorite is Navisworks. BIM 360 docs, and later on in the project you have Glue and Field. So this slide is just to present different options for you, different workflows that you can implement at your firm using several tools. But all this, the end goal is to help you implement a pilot project. And these are some of the software available to you when you purchase the Architecture, Engineering, and Construction collection. So as you can see, you have Revit, you have Civil 3D, you have Navisworks, you even have like add-ins such as the structural analysis for Revit, add-in which basically allows you to run static analysis of structural designs in the cloud directly from Revit. You also have Insight. You have cloud renderings. So these are just like just a list of tools that you will be able to get if you have the Architecture, Engineering, and Construction collection.